Okay, let's just jump right into it. Today we're looking at one of the absolute craziest engineering mysteries of the ancient world. I mean, we're talking about a literal secret formula that has survived millennia. It's weathered empires collapsing, endless wars, and basically everything Mother Nature could possibly throw at it. So in this explainer, we're going to decode exactly why ancient Roman concrete lasts 2,000 years and how we're actually still learning from their absolute genius today.
Because honestly, it's a massive paradox, right? We live in an era with unbelievable technology, but we see modern concrete, bridges, highways, massive buildings, just start to crack and crumble after maybe a few decades. Meanwhile, structures built by the Romans, back when the Caesars were walking around, are still standing strong. So how on earth is our scientifically engineered concrete getting outlived by ancient masonry? Let's figure it out.
Section 1, the 2 Millennium Mystery. To really get to the bottom of this, we need to look at the hard evidence. We're talking massive structures that have basically just laughed at the laws of decay for over 2 millennia. And that brings us to our prime suspect, really, Caligula's Wharf. This thing was built right around the time of Julius Caesar, meaning it's been sitting in incredibly harsh, corrosive seawater for 20 centuries. 20! And it's still in genuinely good shape. Just think about that for a second. Saltwater is absolutely brutal. It eats right through modern reinforced concrete, rusts the steel inside, and completely breaks it apart. But Caligula's Wharf? It's just survived 2,000 years of pounding salt and waves. To figure out how, we've got to look inside the mixer.
Which brings us to Section 2, Ashes, Blood, and Milk.
When you actually look at the historical records and analyze the chemistry of Roman mortar, the recipe sounds less like structural engineering and, well, a lot more like ancient witchcraft. Along with your standard lime and water, the Romans were throwing some seriously weird stuff into the mix. First off, a very specific type of volcanic ash, or tuff. But that's not even the crazy part. Texts show they actively dumped animal blood, milk, and even lard into their concrete. I know, mixing animal fat and blood with volcanic ash sounds super primitive, maybe even a little gross, but actually, the Romans were acting as incredibly intuitive chemists. They didn't know the molecular science, obviously, but they knew exactly what these things did physically. And honestly, this is where the ancient world totally high-fives modern science. If you compare the Roman approach, the blood and the milk, to what we do today, it's wild. Today, we use these highly complex manufactured chemical admixtures called air-entraining agents and plasticizers, just to make our concrete workable and stop it from freezing. Well, the Romans got the exact same result using stuff from the farm. They used these bizarre organic ingredients specifically to get better workability, which let them mold and pack the concrete way more effectively. Let's look at the blood for a second, because this is fascinating. Hemoglobin, the protein in animal blood, is actually this incredibly powerful natural air-entraining agent and plasticizer. When you mix it into wet concrete, it whips up these microscopic little air bubbles all throughout the material. That does two things. First, it makes this heavy, rocky sludge way easier to pour. But second, it completely changes the internal structure of the concrete once it hardens, which massively boosts its durability. It's just wild to think that this ancient little workability hack was secretly bulletproofing their buildings for the next 2,000 years.
All right, Section 3, Decoding the Pozzolanic Reaction.
Okay, so blood and milk are definitely cool, but they are only part of the story. To find the real scientific smoking gun here, we have to look at the geology of ancient Italy. The Romans figured out that this one specific volcanic tuff, found near the village of Pozzuoli, right in the shadow of Mount Vesuvius, had frankly magical properties. Mix it with lime and sand, and boom, you get a mortar that is unbelievably strong, especially underwater. Because of where it came from, this highly siliceous ash became known as pozzolana, and this stuff was the absolute key to the whole mystery. It fundamentally rewired the chemistry of the concrete while it cured.
Let's break down the chemistry here simply. When normal cement mixes with water, you get a reaction called hydration, and a major byproduct of that is something called calcium hydroxide. Now, structurally speaking, calcium hydroxide is basically useless. It gives you no strength, and even worse, water can just dissolve it and wash it away, leaving the concrete weak and full of holes. But when you add pozzolana to the mix, a totally new secondary reaction kicks in. That volcanic ash essentially hunts down that useless calcium hydroxide and chemically reacts with it. The result is this incredibly dense, practically waterproof stuff called CSH gel. So the Romans were literally taking a weak, useless byproduct and accidentally turning it into a super strong, impenetrable glue.
And what's really amazing is how this one single chemical reaction essentially gave Roman concrete superpowers. By eating up all that calcium hydroxide, the pozzolana made the concrete super watertight, which totally stopped it from rusting or corroding from the inside out. It also lowered the heat generated while the concrete was curing, which is a huge deal because it stopped massive structures from just cracking apart right away. And probably most importantly for stuff like Caligula's warp, it made the concrete incredibly resistant to sulfate attacks, which is basically the ultimate shield against corrosive seawater.
Moving on to Section 4, the power of workmanship. So yes, they had a genius recipe, but honestly, a great recipe doesn't mean much if you don't have a master chef in the kitchen. The reason Roman mortar was so vastly superior wasn't just the chemistry, it was also their completely relentless, back-breaking workmanship. Specifically, we're talking about incredibly thorough mixing and long, continuous ramming. They didn't just pour this stuff into a mold and call it a day. No, they physically beat it into submission. By relentlessly pounding the heavy mixture, they manually forced out all those tiny pockets of trapped air. They essentially forced the materials into this ultra-dense state, packing every single particle of that pozzolanic gel as tightly as physically possible. And this whole idea is perfectly summed up by a modern engineering principle that states, impermeability is governed by the constituents and workmanship used in making the concrete. The Romans literally proved this 2 millennia ago. Extreme density. That's the real secret here. If you combine the right chemical constituents, like pozzolana, with the absolutely extreme physical labor of ramming it down, you get extreme durability. Because think about it, if water simply can't get in, the structure absolutely will not rot from the inside out. It's that simple. Finally, Section 5, Ancient Lessons for Today. Which brings our whole investigation right back to the present. Because for me, the absolute coolest part of this whole explainer is that modern engineers are finally catching up to the Romans. Today, the global construction industry is actively copying these ancient methods. We make something called Portland Pozzolana Cements, or PPC for short. Now, we aren't exactly hiking up Mount Vesuvius to grab volcanic ash anymore, but we do use modern industrial byproducts that act exactly like it. Take fly ash, for example. It's a byproduct from thermal power plants, and we just blend it right into our cement. And just like the Roman tuff, it reacts with that useless calcium hydroxide, lowers the heat, and massively improves how waterproof and durable our modern concrete is. And you don't have to look far to see this ancient knowledge in action. Just look at our most ambitious modern megastructures, like the mighty Hoover Dam. When engineers were designing this unbelievable block of mass concrete back in the 1930s, they knew that if they used standard cement, the heat would build up and the whole thing would eventually crack. So, what did they do? They relied heavily on the exact same pozzolanic principles that the Romans figured out. By doing that, they built a practically impenetrable wall with a predicted lifespan of well over 1,000 years. We are quite literally building our future using the secrets of the past. Which leaves us with this final thought to chew on. The Romans took volcanic ash, some animal blood, and a ton of relentless physical labor, and they engineered a legacy that outlasted their entire empire by 2,000 years. We are just now decoding how brilliant they actually were. It really makes you stop and wonder, doesn't it? With all of our advanced chemistry, our supercomputers, our cutting-edge technology today, what modern engineering secrets are we building right now that will completely puzzle and amaze whoever is walking the earth in the year 4000? Thanks so much for hanging out with me for this explainer. Keep asking those big questions, and I will catch you in the next one.